Grade 10s, AP Maths kids, clever kids, well done for pitching up, showing up for yourself, for your own education. We are on to equations with surds today. The word surd just means square root. That square root symbol can be called a surd. Now remember, we have already worked with the square root of negative numbers, and we know that if what lies underneath the square root is negative, then we're dealing with a non-real number, which we're okay with because we've been doing that thus far. Fortunately, this exercise doesn't deal with non-real numbers. All the x values are positive answers, and we are required to solve for x, and x is usually under that surd, under that square root sign. So we treat this as a normal equation, and we follow our order of operation rules by performing inverse operations in order to get x all by itself. But one thing I want you to take note of is that the square root of anything, if it is given to you in a question if you see a square root symbol in the question, like here we have the square root of x minus 4, that represents the square root of anything, right? Note that there is an invisible plus sign in front of that square root, so we have been given the positive version of the square root. I know if I ask you, what is the square root of 81? You are expected to tell me that it's either positive 9 or negative 9. But if I give you root 81, I am implying the positive version of the square root. If you write down a square root in order to undo a square, that's when you put a plus minus in front of your square root sign, when you write it down. But if it's in the question, it is a positive. Right, so let's get into this. And you'll see the importance of that in a little while in example number 2. Right. In order to get that surd all by itself, the square root of x minus 4, I'm going to take my 5 over to the other side of the equal sign, and it's going to become positive 5. Easy peasy. Now, to get one step closer and to get x all by itself, we need to undo the square root. And to undo a square root, you just square. You raise the left-hand side to the power of 2, but what you do to the left, you do to the right, and that's how we end up with x minus 4 equals 25. The square and the square root symbol cancelled each other. And last but not least, we kick the negative 4 over, and we get x is equal to 29. Not bad, right? The only thing is, we need to always, NB, please do this every single time you have a surd equation. You must check your answer. So just substitute that 29 in the place of x and check that the left-hand side of the equation does equal the right-hand side. So I've substituted 29 minus 4 underneath the square root. 29 minus 4 is 5. Square root of 5 is 5, and 5 minus 5 gives you 0, and your right-hand side is 0. So this solution is valid. Whoop, whoop. Example B has this problem. Look at that little ominous pink plus sign hanging in the air over there. You're going to see why it's important. Now, if we want to get this surd all by itself, we're going to have to kick the negative 5 over to the other side. And we'll end up with the square root of x minus 4 equals negative 5. But that square root is a positive square root. And so how on earth could a positive number be equal to a negative number? It's just impossible. We can't have a positive something equal a negative something. So we have no solution for this equation. Here's another example. If we solve for x here, we are already at the stage where we can square both sides and get rid of the surd. So if we square the left-hand side, we'll just drop the root, and the right-hand side will become x squared. Now I hope you are thinking trinomial, trinomial, trinomial. Take everything over. You could have brought it all over to the left, but then you would have had to get rid of negatives. So I just kept the x squared where it was, and I brought the 5x and 6 over. Of course, they changed sign. And now we have a trinomial that we can factorize. Don't tell anyone I said this, but if you use your calculator to factorize, that's fine. As long as you show me the brackets, and as long as you have your final answer as x equals 6 or x equals -1. NB, what must we not forget? To check our answers for surd equations. Look at the left-hand side. Substitute in when x equals 6. Instead of having 5x plus 6, we'll have 5 times 6 plus 6, which will give you the root of 36, and that gives you 6. Both of these solutions work. Even when you substitute in the place, substitute -1 into the equation, we'll get square root of 1, which is 1. So both of these solutions are valid. Aha, this is probably the trickiest type of surd equation that you could get, merely because we're going to introduce a little bit of K method into this as well. Let's have a think about something. Yes, I'm sure you can see. Oh, first things first, when you see a fraction, and please note that this is very important, especially for the lesson where we had equations with fractions, and I failed to mention this. I was so excited to solve for x that I forgot the bottom of a fraction, the denominator, can never be 0, otherwise the entire equation is undefined. So you just, somewhere on the side of your page, you set up a restriction. So here, if we were to look at these denominators, can you see that if x plus 2 was equal to 0, we would have undefined fractions? So if x plus 2 is 0, that means that x would be equal to -2. So we cannot have x being equal to -2. So we just list it as a restriction from the get-go. Then I'd like you to think about a certain concept. We have a repetition of x plus 2 happening over here, except one has a square root and one doesn't have a square root. So we can't apply the K method straight away. We've got to be clever about our K method. If you have a think about it, the square root of something squared, if you square a square root, you would cancel that root, right? So if we let k be the square root of x plus 2, and then we were to square k, we would just end up with x plus 2, right? So this fraction, we can use K method with this fraction where we have a k and a k squared involved. So instead of saying the square root of x plus 2, we can replace it with k. And then instead of saying x plus 2, we can replace it with k squared. And now we're at the normal way of solving an equation with a fraction. First things first, set up a restriction. We cannot have k be equal to 0 because then our entire equation is undefined. But we can find an LCD, and that is k squared. Multiply 1 by k squared, multiply -4 by k, and leave 32 as is, and voila, we are closer to that trinomial format, which can be factorized, and we can find a value for k. K will be 8 or k will be -4. Unfortunately, the question wants us to find a value for x, not for k, so we have to take this even further and substitute again. We made k be the square root of x plus 2, so now we need to remember that. And instead of having k equals 8, we're going to need the square root of x plus 2 equals 8. So that's exactly what we're going to do. Instead of having k equals 8, we write the square root of x plus 2 equals 8, or instead of having k equals 4, we replace our k with square root of x plus 2. Now we're very close to the end. We square both sides. Oh, looking at this equation on the right, we have a positive square root is equal to a negative 4. How can a positive be equal to a negative? It's not possible, so there's no solution there. But this equation on the left, the square root of x plus 2 equals 8, we square both sides. Sorry, I'm being lazy here, not showing all the steps. If I square the square root, if the square root sign falls away, if you square 8, you get 64. And if you take if you take 2 over, we'll end up with 64 minus 2, and so our final answer is x equals 62. But remember, equations with surds, you have to check your final answer. And in this case, when you substitute 62 into the left-hand side of the original question and simplify, you get a half. If you substitute 62 into the right-hand side of the original equation, you get a half. So this x equals 62 is valid because our left-hand side equals our right-hand side. Great. I would like you to carry on and complete the rest of this exercise. Look under the memos folder for your solutions, and please, please, please feel free to reach out to me if you have any queries.